Hello guys, good day. So in today's video, we will be tackling about the stress on thin wall pressure vessels. So the first topic that I am going to discuss with you is the thin wall cylindrical tank or pipe. A tank or pipe carrying a fluid or gas under pressure is subjected to tensile forces which resist bursting. Develop across longitudinal and transverse sections. So, ang pipe is subjected for tensile force. This one, no? Tensile forces. Na mo na siya reason why is it na mga pipe, mga tank dili ma-burst because of the tension, tensile force, no? Because of the tensile force. If this is the pressure kani, marag iyang may kag-pressure, so ang pressure is i-produce no within sa body sa tank, and ang button sa body is to resist. So na may mga tensile forces, that's why it resists sa pressure. As you have noticed, this is the longitudinal or longitudinal section, transverse maning isa longitudinal section. As you can see, and explain po datong mga earlier topics na from top to bottom, so 2/3, 1/3 ang force makita dira. And this happens na, di ba na may giingon man ganina, it said na i-produce na tensile force. So this would be the tensile force, no, at 1/3 from the bottom, and ang center is the force, which is tensile up, going out sa, ang iyang direction is away from the body, while ang compression is going. So this is tensile force produce no sa body or sa tank or pipe. S as the siya kanang considered na height, certain height sa experimentation. For example, kanini siya na gikuha da, muna siya ang projection kundakon. As we know, ang force is will be developed because of this no diagram, triangular, may mga force ana. So transverse section and longitudinal section. So to determine the tangential stress in the pipe wall, let us cut a section of length S along the diameter. The forces acting on this section are total pressure F, kani F, to the internal pressure, and this is to be resisted by T, which is tensile forces, no? Which is the total stress of the pipe wall. So applying sa equilibrium condition wherein summation of forces along horizontal or X, wherein going right is positive, and F therefore equals to 2T. Diba? Ang F is against man sa dua ka T. So that's why nangani. Therefore F equals to, we know na ang pressure equals to, sa manang pressure, it would be F over area. So that's why kung ato siyang cross multiply, so we can have the values for force as pressure times area, or Using the illustration, ang area nato is D, as considered siya as rectangular because of this kaning vertical projection of the wall. So PDS, no, length times width. Width, I mean length, S, width ang D. And T, ang tensile force, coming from the tangential stress, which is ST, equals to T over area. Same na siya concept ng pressure, ang stress. So therefore, kung i-cross multiply, it happens na tangential stress times area sa wall, to be specific, or simply, sa man, S sub T times S kaning length and the thickness, ST, na small. So, kung ato ning panggamito ng mga values sa F and T, therefore, F is PDS equals to 2 times ST times ST. So, therefore, our kung ato ning makancel ng S, so atong PD equals to 2STT, or ST is PD over 2T, diba? So this one again, tangential force, tangential stress, pressure ang P, diameter ang D, and ang T is thickness. To determine the longitudinal stress, let us cut the cylinder across its length as shown. So, when I say transverse, thinking na kaniha, and dari ang cutting. Longitudinal section, wherein paana. Pero ato ma-produce sa longitudinal section is the tangential stress. Ang sa ani magud ang this is the tank or pipe, makabantay man mo na yung mga force na paana, no, transverse section ang considering ani, and it has produced a longitudinal SL. So dari, no, kabantay mo S sub L and is S sub T. So ang F and T, so lahira, no, longitudinal, pinataas sa part sa body or sa pipe, and ang transverse is this one na makaproduce og longitudinal stress. So we need to find the S sub L. So again, thinking na ay thickness ning pipe, ST tapos dari D. So thinking, no, na pod, considering the SE, static equilibrium equation, one of those is summation of forces along X or H equals to 0, wherein all going to right is positive. So F equals to T. So sir, nga naman, as 1 na lang imong consideration ani. Because it acts as 1 na lang, no, thickness. Kung ikaw force, ang imong i-produce lang na force is as 1 lang. Di ka pa sa longitudinal, duha sila kay nahati na biya, di na sila as 1. So kani as 1 na tanang mga tensile forces. And thinking, now we consider the sa man, the circular or the shape no sa cylinder base niya, which is as we have known F equals to PA, and the A is the area of the circle over no pi d squared over 4, and our T is SL, di ba, gikan sa longitudinal stress equals to T over area A tapos wall ni Dare. And we know the wall is the circumference. Circumference pi d times thickness. Diba, circumference considered as like perimeter. A section lang siya, di siya area. So let's do the math here. F equals to P times pi d squared over 4 equals to SL, S sub L, tapos dali no, SL pi dt. So pi dt. We can cancel the d. Same naman na sila, as well as the pi. Isa na lang di ang d. And so pi d over 4 equals to S sub L pa na lang t, di ba? So S sub L equals to PD over 4t longitudinal stress. So, as you have observed, tangential is PD over 2t, and the longitudinal stress is PD over 4t. And take note na ang P here is that internal pressure. Ang P dariha minus external pressure. Internal pressure minus external pressure. So that is the 10-volt cylindrical tank or pipe. Next topic is the spherical shell. So 3.6b. Spherical shell. Spherical. Spherical shell. If a spherical tank of diameter d and thickness of t contains gas under a pressure of P, stress at the wall can be expressed as, so naghatag na siya formula daan, wall stress S sub W O equals to PD for T, wherein if this is the shell, no, sorry for my illustration. Kung na thickness dari, na and thinking na shell ni siya. So therefore, ang internal diameter is D lang, tapos thickness T. Basta shell, no? As you can see, internal diameter and the thickness, both sides. So that is the spherical shell. Same formula with S sub L, longitudinal stress. And the next topic is the spacing of the hoops. of a wood stave pipe. So kani, this one is, for example, when you say stave pipe, pipe siya, no? So this one, outside ko na siya hoop. Ang spacing ana is S. Spacing. And this are the hoops. So spacing is equals to 2 ST AH over PD. Again, this one is small s. And it means spacing. ST is tangential stress. Pressure, diameter, EH is cross-sectional area of the hoop. Para ma-separate ninyo, no, di mo malibog, let's say this one is allowable tensile stress of the hoop. So P is the internal pressure in the pipe, and D is the diameter of the pipe. So diameter, this one of P. So I think you're ready with the problems or the examples. So example number 1. At 250, so the first problem is a 250 millimeter diameter steel pipe, 10 millimeter stick carries water under a head of 45 meters of water. Determine the stress in the steel. So unsa na head? This one is the pressure head, and the stress na indicate is the tangential. So we use the S sub T. So solution, no? S sub T equals to PD over T2. Since nagkon siya og pressure head, so therefore ang P equals to unit weight times height, and water man, so unit weight is 1. I mean 9.81 times 45 meters. So it is 441.45 kilopascal. So let's input the values, no? 441.45, and the diameter is, convert ato ni og meter, so 0.25. Y 250 mm times, so cancel, therefore 0.25 meter. And ang ato ang tool, ang thickness is 10 mm, so 0.01 meter, no, ang thickness. So therefore, our tangential stress is 5,518.125 kilopascal or 5.52 megapascal. Diba? Magulang lang si mega kang kilo. Si kilo kay by 10 to the power of 3. Si mega is by 10 to the power of 6. So this one, an answer. So second problem tang. So the second problem or example is we are asked to determine the required thickness of a 500 millimeter diameter steel pipe to carry a maximum pressure of 6,500 kilopascal. If the allowable working stress is 120 megapascal, so the thickness, no, unknown. So therefore the solution is first identify na to ang stress na gamiton. May working stress, therefore it is the tangential stress. So the solution or the formula to be used is S sub T equals to PD over 2T. Ang ST nato or S sub T is 120 megapascal or 120,000 kilopascal. Ang D nato is to be known. Diameter is 500 mm or ato na siyang imog meters, so 0.5 meters, and P is 6,500 kilopascal. So I think it's okay na to input the values, no. So 120 kilopascal or kilonewton square meter equals to pressure is 6,500 kilonewton per square meter times diameter 0.5 meter over 2T, so cross multiply. So i-swap na to ang T and the 120. So 6,500 kilonewton square meter 0.5 meter 2 times 120,000 kilonewton square meter. Again, kilopascal is kilonewton per square meter. Cancel. So the answer is 0.0135 meter or times na to sa 1,000 millimeter. Cancel ang M. So itong T is 13.5 millimeter. So this is the answer. So the next example is, so the third problem is a wooden storage tank is 4 meters in diameter and is filled with 6 meters of oil, which is having a specific gravity of 0.80. The wood staves are bound by a round steel bar 12 millimeter diameter whose allowable tensile stress is 124 megapascal. What is the required spacing of the steel bar near the bottom of the tank, neglecting any initial stress? So, i-draw sa nato ang illustration. So, ang oil is 6 meters, no? Tapos 4 meters ni. And naatay spacing. This is the round steel bar. So gamito na to ang formula for the spacing of hoops of a wood stave pipe. It is solution. S equals to 2 ST AH PD. So una to sa P, our P is unit weight times height or 9.81. So ang gamito nato no is ang oil 0.80 times height niya is 6. So ang P therefore is 47.088 kilopascal. Ang ST or the tensile stress is 124 megapascal. The area sa cross-sectional area sa hoop, which is kaning round steel bar area ani, it would be pi d squared over 4 or pi, ang d is 0.012 squared over 4 or 1.13 by 10 to the power of negative 4 square meter. So means dagan kinig 0 i-convert lang ani. Ang kwan jud niya ani is 0.00113 square meter. So 1, 2, 3, 4. So 1.13. So therefore S nato is 2 times 124,000 ato i-convert siya kilopascal no, 1,000 kilopascal times ang area nato is 0.000113 square meter over pressure is 47.088 kilopascal times diameter. Ang diameter na to is 4 meters. So cancel meter nang nabilin, therefore the spacing is 148.8 millimeter. Or ano siya una, 0.1488 meter times 1,000 millimeter over 1 meter. So kani. So that's it for the topic or the last topic of the chapter 3. It is the stress on 10-volt pressure vessel. So goodbye and thank you for listening.